So this question here is question number 13 from exercise 1, alcohols, phenols, ethers of phase 5. So the question is like a descriptive one wherein we need to derive what are the different components. The question says compound B, an isomer of A in the problem 4, which we can get it from the previous question, okay, is reacting with borane in THF followed by oxidation with hydrogen peroxide. That is nothing but hydroboration oxidation which is happening. So here I have written what is the condition. So D is undergoing what reaction? Hydroboration oxidation. Now during hydroboration oxidation, we all have learned very well that whenever this reaction is happening, it is going to be anti-Markovnikov's addition, wherein it results in anti-Markovnikov's product, which will be an alcohol, and preferably the alcohol is a primary alcohol, which we are going to get here. Now, the same when we take it, so the oxidation of E with KMnO4 or acid dichromate, that is what is the next statement given, is giving a chiral carboxylic acid F. So oxidation, either you take a KMnO4, either you take a dichromate, you are going to get a chiral carboxylic acid. Then followed by ozonolysis of D. The next statement says that ozonolysis of D after reduction with zinc. That means nothing but what you can say reductive ozonolysis. This condition is what? This is reductive ozonolysis. Reductive ozonolysis. So as long as you can identify the reagent, there's no problem in solving the question. He is giving us what? It is giving us the compound G. Compound G is obtained by reductive ozonolysis of our reactant D. Now, there is no other hint given other than the last statement. The last statement says that the compound G is obtained by oxidation of 2-methyl pentanol, pentanthreol. That is the only information given to you. So let's start from there because that is a known molecule and you have to do such questions through reverse approach, and so we are starting from there. So 2-methyl pentanthreol, I have taken it here. 2-methyl pentanthreol. Okay. So on oxidation in presence of KMnO4 is giving us G. So the same thing I have written here. So what will happen if ever this alcohol is undergoing the reaction and giving us the respective product G is nothing but we are going to get an aldehyde or a ketone, isn't it? So the same thing we are going to take here. So alcoholic group. Now you can observe this is CHOH. That means this is a secondary alcoholic group. So secondary alcoholic group on oxidation should always give us a ketone. So that is what we are going to write here. CH3, CH3, C double bond O, CH2, CH3. Now the same ketone is obtained by ozonolysis of the alkene D. So how are we going to get it? We are going to get that by taking this ketone or conversion of this ketone into an alkene. How do we do that? Here we are not given with any other information. So we are assuming that the other part of it is just a carbon. So that B here should have the same skeletal structure. So I am taking the same skeletal structure CH3, C, and now the position of double bond O should be replaced by what? Another carbon, because we don't have any other carbon chain mentioned. So CH2. So our compound D is this. Our compound D should be having a probable structure like this because there is no other alternative possible for us. Nothing is mentioned. Now let's see how it will be working out for the next step. That is oxidation in presence of the respective diborane or hydroboration oxidation should give us a chiral alcohol. So this I am taking B2H6 followed by H2O2. So where will the oxidation be happening? At this particular carbon, because it has to be a primary alcohol. There are two carbons here. One is tertiary, one is primary. So only primary carbon will form an alcoholic group. So what is the alcohol formed here? CH3. Retained everything similar, just the alcoholic group at the primary position. So CH, CH2, CH3. As you can see, here we have one isopropyl group, one hydrogen, one methyl group, ethyl group, and one CH2OH. That's why this particular carbon here is a chiral carbon. So this is a proper satisfactory explanation here which we could get. Now this is undergoing oxidation here. This particular compound is undergoing oxidation. So what we should get? We should be getting an chiral carboxylic acid. So the primary alcoholic group is going to convert into an acid. So CH3, CH, CH3, CH, COOH, primary alcohol will always convert into an acid on oxidation if it is not controlled. So we know that very well. So again, the same carbon is going to be the chiral carbon here. So whatever instruction has been given to us, that is how we can solve the question as such. As you can see, we have identified what is D, what is E, and F and G. So what is G? This is the compound G, which is a ketone. D is an alkene, okay? And what do we have? F. F is the acid. This is our F here. And this here is E. This is E here. So this is how we can solve the question. Thank you.